Today in class, we filled out this graphic organizer that helps summarize the 4 different ways you could find the center of a triangle. The 4 different centers is what they're called. We don't just have one center because there's different ways to find it. So we've got the perpendicular bisectors. When I find those, they meet all at one point, and that one point is the circumcenter. Angle bisectors all meet at the end center. Now these are the 2 new ones, and we didn't really get into these. So let's explore these a little bit further. The centroid says it's created by the medians. So let's look at medians. What a median is it's a segment that goes from any vertex. So it has to have a vertex on one side. Notice back here, for the circumcenter, for instance, these are the perpendicular bisectors here. They don't go through a vertex necessarily. In center, they are angle bisectors, so they definitely have to go through a vertex because it's the vertex or the vertex of the angle that you are bisecting. Okay, so sometimes we do go through vertices and sometimes we don't, so that's significant. So a median goes from a vertex to the midpoint of the opposite side. That doesn't look right, but if it were, these 2 pieces would be congruent. So I'm going to go ahead and I'm going to do that as a construction. Remember that if I want to find the midpoint, the easiest way to find the midpoint is to find the perpendicular bisector, see where it crosses your segment. I'm hoping this is a decent compass, because if not, life's going to be yucky. I felt like it moved a little bit there, but maybe not. That looks about halfway. So this is my perpendicular bisector. So what that tells me, and I don't have to have all that marking, the key idea here is I was looking for the midpoint and there it is. So there's the midpoint of BC, and I can do this again. To find the midpoint of AC. And I'm just looking for midpoint. I don't really care about the perpendicular bisector, so I'm going to make it kind of light. This is what I'm looking for, midpoint of AC. And finally, for AB, here is the midpoint. So if I want to draw the medians of this triangle, I'm connecting any vertex to the midpoint of the opposite side. So A goes to over here. Let's give these names. Let's call these Q, R, and S. So A goes to R, B goes to the midpoint of the opposite side, which is S, and C goes to the midpoint of the opposite side, which is Q. It's not at all confusing which midpoint you have to connect a vertex to, because here's the thing. I'm connecting C to the only point it's not already connected to. It's already connected to R and B on this side and S and A on this side. So I'm connecting C to the one point in this whole triangle it's not connected to. That's the midpoint of the opposite side. Same thing goes with BS. Unintentional there. And the same thing goes with AR. So those are medians. AR is a median, BS is a median, and QC is a median. Okay? These are all medians of triangle ABC. The medians all meet at a point. They are all concurrent. They meet at a single point, a point of concurrency. And just like with other things, we've got the point of concurrency having a special name. The special name in this case is the centroid. I'm going to call the centroid T. Okay, so the centroid is the point of concurrency of the 3 medians of a triangle. Really, if you draw even 2 of the medians, you'll still find the centroid, because once you have 2 of them, they intersect at that point, and the 3rd one will intersect there also. Now here's the special property that the centroid and the medians have. It's not equidistant from anything, okay? That happened with the end center, that happened with the circumcenter. This point is not equidistant from the sides or from the angles, so don't worry about that. What it is, though, is we have a proportion. Looking at the whole median, this point, the centroid, is 2/3 of the way from the vertex to the opposite side. Let me write that. The centroid is located 2/3 of the way from the vertex to the opposite side, or which is the midpoint on the opposite side. So if you start on the one that's the vertex of a triangle, 2/3 of the way to the opposite side is where the centroid is. From B to S, that means this is 2/3 of the whole thing. Going from C, CT is 2/3 of the whole thing. Now the easiest way to look at that is to think of the whole median as having 3 parts, because 2/3 means 2 parts out of 3. So if you think of the whole median as having 3 parts, 2 of them would be on the side with the vertex, and 1 of them would be on the side with the midpoint. Here's the centroid. It's the one that does the dividing. So here's what that looks like. I'm going to take this and divide it into thirds. One of the thirds is between these two. There. This is 3 pieces. Piece 1, piece 2, piece 3. This is how it works on every median. 2 pieces out of 3 are between the vertex and the centroid, and the third piece is between the centroid and the midpoint. So what that means, for instance, is let's say the whole thing had a length of 15. If this whole thing had a length of 15, then I would divide that into 3 pieces and say, okay, this is 5, this is 5, this is 5. Which means this part, 5 plus 5, is 10. This part is 5. What's the relationship between 10 and 5? This part is twice as big as this part. That's always going to be true, because 2/3, 2 pieces out of 3, is twice as many pieces as 1 piece out of 3. Okay, so what if I wasn't given the whole thing? What if I was just given this part? I was told from the vertex to the centroid was 8. Well, that's 2 parts, so I would figure out that means each part must be 4. So 4, 4, 4. Okay, so the whole thing would be 12. I have 4, 4, and so that means this part over here must be 4, because they're 3 equal pieces. So the whole thing is 12, or just this side is 4, or whatever. All right, so looking at that in the context of the triangle, let's say we know that BS has a length of, oh gosh, I don't know, let's say BS has a length of 24. If BS has a length of 24, BS is the whole thing. So I'm going to divide that into 3 equal pieces. So that means from here to here, from here to here, and from here to here. 3 equal pieces. The bigger piece gets divided into 2 parts, and the smaller piece is 1 part of the whole. So part 1, part 2, part 3. 24 divided into 3 pieces is 8. So that would mean this is 8, this is 8, and this is 8. So from B to T is 16, and from T to S is 8. All right, let's look at what if I were told that AT has a length of 12. Well, AT is from vertex to centroid. It's the bigger piece. So that has how many parts out of 3 in it? It has 2 parts out of 3. So 1, 2, 3 parts total. 2 parts are over here. So if 2 parts equals 12, then each part must be 6. So now if they ask me what AR is, it's 6 times 3, or 18. If they ask me what AT is, I already know it's 12. If they ask me what TR is, it's just 6. Final example, looking at segment QC, or median QC. Let's suppose that I know that QT is 7. Which part of this is bigger? This part over here, from the vertex to the centroid, is bigger than midpoint to centroid. So QT is the small part, which means it's one of the pieces out of 3. If this is one piece, this over here is 2 pieces. So that's 7 and 7. Another way of looking at that is the small part will always be half the big part, or the big part is 2 times the small part. So we have Q to T is 7, then T to C would be 14, and all of QC would be 21. And that's how you deal with medians. Now the last one on here is about orthocenters. Orthocenters are pretty easy because they don't really have any special properties in terms of length. You just have to know what it's made from. It's made from the altitudes. And if I want to make an altitude is a segment that goes from a vertex to the opposite side in such a place that it's perpendicular to the opposite side. So here's how we do that. We're going to do this, oh, hang on, I messed something up. There we go. We're going to do this as one of our other constructions, so this might make more sense once we've done that. But this is a perpendicular segment. Notice that it goes through the vertex and it doesn't go through any particular point on the opposite side. It just has to make a right angle. So it goes wherever it's going to make a right angle. So here's my altitude. It goes from B to make a right angle with AC. Sometimes that ends up being outside the triangle, which is kind of weird, but it happens. Okay, here I'm going to extend BC because I don't think it's long enough right now. And I'm going to go from A to the opposite side where it would make a right angle. So, well, not big enough. Still not big enough. Big enough. So this one's going to be very close to the edge, but not quite the edge. So here's another perpendicular. And finally, this one, this one's going to be really close to the edge. I'm not sure about this. Let's make this a little longer. And actually, I already know where it's going to be because, again, these points are concurrent. So it definitely has to go through right here. So I'm just going to do that. I'm going to be lazy and just connect it from C going over here. And I know it makes a right angle. So here is the point where all 3 altitudes meet. Each one of those was an altitude because it goes from a vertex to the opposite side wherever it would make a right angle with that side. This is called the orthocenter. That's where all the altitudes meet. There is nothing special to know about the orthocenter. That's it. That's all you got to know about the orthocenter. And I just remembered that there is one more special thing to know about the centroid. If I'm not mistaken, and I sure hope I'm not because then I'd have to cut the end of this video. But the centroid is also the center of gravity of the triangle. What that means is if I were trying to balance a triangle on the point of my pencil, I would want to put the tip of my pencil on the centroid so then it would balance. But that's all you need to know about centroids and orthocenters. Now you really need to be starting to memorize this information because there's a lot of it. So you might want to start working with flashcards or however you can learn this because you have to know everything on here and be able to recognize it from the markings and then use this information.